Okay, so we're moving on to LT6, which is modeling real-world situations using sine and cosine functions. So this problem, it's in the book, and it says after flying 300 miles west from Detroit to Chicago, a plane is put in circular holding pattern above Chicago's O'Hare. The plane flies an additional 10 miles west past the airport and then starts flying around kind of the airport in a circle with a diameter of 20 meters, and it completes one circle every 15 minutes. So it says model the east-west component of the plane's distance from Detroit as a function of time. So then they've kind of drawn the picture out for you. And I think that's pretty helpful on all of these types of problems if you can draw some form of picture. And if not, definitely get a table if they don't give one to you already. This one they gave one to us. And on one side it's the time from the beginning of the circle. So at 0, they're at, let's see, 310 miles from Detroit. So over here is where they're going to start. That's when they go the extra 10 miles. And then they're going to go, let's see, counterclockwise it looks like. And so after 3.75 minutes, they're back at 300 miles. At 7.5 minutes, they've actually gone back 10 miles, so they're at 290. At 11.25 minutes, they've gone 300 miles, so again, kind of back to directly above the airport. And then at 15 minutes, they're back to where they originally started, so 310 miles from Detroit. So the next thing that you're going to want to do is graph the function, and we've got it graphed up here. So we've just graphed our point 0, 310, 3.75, 300, 7.5, 290, 10 point, or 11.25, 300, and 15, 310. And then you're just going to go through, so using kind of our formula from the investigation packet, it's in the paragraph right under where it starts task 3. It talks about plugging in the values for amplitude, period, phase shift, and vertical shift. So we'll just start with our amplitude. And again, amplitude is 1/2 the distance between our maximum and minimum values, which in this case are 310 and 290. So 1/2 of 20 is 10. So that's why our A is going to be 10. Then our period, it's 2 times the time from the max distance minus the time of the minimum distance. So literally from, let's see, from the top of our hill to the bottom of our hill. And if you wanted, you could do it from hill to hill, which is what we've kind of been doing in class. So from hill to hill, we go 15 to 0. So we know our period's 15. Well, a normal period is 2 pi. So when we are trying to plug it in for k, we're going to take 2 pi divided by whatever our period is. So when we talk about like the normal parent function, y equals cosine x, our period is equal to 2 pi, but when we plug that in, 2 pi divided by 2 pi is just 1, which is how we get our 1 here. And then on this one, we don't really have a phase shift because it follows the shape of our normal cosine graph. And I think I forgot to mention, I chose cosine because cosine normally starts at 1 and then, you know, kind of goes down and then back up versus sine, which is going to start at 0 and then go up and down. But you could choose either. It would just affect whether you have a phase shift or not. And then our vertical shift, it's similar to finding amplitude, but it's 1/2 the max distance plus the minimum distance. So we take 310 plus 290 to get 600. Half of that is 300. And your vertical shift in this case at 300. So if we think about our midline, and they've actually kind of got it drawn up there, our midline is actually y equal to 300. So your vertical shift is going to be where your midline is as well. So we'll plug in 0 for C and 300 for H. And that means once we've got all of those in, we get y is equal to 10 cosine 2 pi x over 15, and then plus our 0 for C, plus our 300 vertical shift. So then this is your before class problem. And it says, throughout the day, the depth of the water at the end of a dock in Bar Harbor, Maine, varies with the tides. The table shows the depths in feet at various times during the morning. So they gave you your table. So the first thing you're going to have to do is graph it. And once you've graphed it, you'll start on part A, choose either sine or cosine to figure out which one it looks closer to. And then you're going to have to go through and find amplitude, period, phase shift, and vertical shift, if there are any. And then once you've got your function, you'll plug in 9 a.m. and 3 p.m. to find your depth. So you'll plug those in for your x. And then for C, you'll plug in 10 for y, and you can figure out what values is going to be applicable for that. So what x's are going to give you at least 10 feet of water.